Hey, welcome to the Engineer's Workshop. One of the things I deal with quite often in my day job is measuring buildings for the installation of equipment. So you got to develop a set of tools and techniques to help that, because one of the challenges of that is how do you measure something that you can't reach or that you don't have a direct line of sight on. So it boils down to establishing some reference lines, which you can do pretty easily with tape measure and a marker on the floor, but you have to transfer those reference lines a lot of times up 20 or 30 feet, and for that you need to employ a laser so that you can shoot some level and plumb lines from your reference points on the floor and pick up edges of beams on the ceiling to know where they are. And then also, if you need to know the height of something, a device like this, which is a laser tape measure, I guess you could call it. And these are both by Hilti. So this shoots a beam on the ceiling, or if you hold it horizontally on a far wall. And once you click it to take the measurement, you can see that this is 10 foot 6 and 31 seconds from this surface. This thing is crazy accurate. If you were to stretch a tape from here to that point, you'd get the exact same measurement. And this thing is good for, I think, like 600 feet with a special reflective target that comes with it. But it'll do, 50, 60, even 100 feet just shooting on a flat surface. So these are the tools I use. I'm going to use them for this beam. Got to place this beam up under the rafters of the building, and rafters form a shallow angle. So I need to establish the length of the beam, and then I need to know where the ends of that beam are going to land on the underside of the building frame. It needs to be centered about the exact center line of the building. And to do that, we're going to use these tools, and I'll show you that. Let's get started. Supposed to get some decent tension on a tape. So we have 25 feet and 3/16. 25 feet and 3/16. And for you metric lovers, you can do the conversion on that. So half of that is 12 foot and 3/32. I'm going to go ahead and mark that on the beam. Check that, measure from the other end, see if we get the same spot. First mistake of the day, 12 foot 6 and 3/32. That's more like it. So there's my ridge point. This is the rafter that I'm going to be hanging the trolley from. This is the same rafter that I'm currently using with the Yale hoist, and did the initial disassembly on the lathe, parts of it right there. Just to get a rough idea of how high this is. First click turns on the laser, get it to where it is registering on the beam. And this floor is not level at this point, so there we go. (17'8". Now what I'm trying to do is get that laser dot right on the split line between the two halves of the beam. And I can see that I'm just to the left of the split. I'd say that's about perfect. Okay, from that, I'm going to make a mark on the floor. There's my intersection directly under the beam. I'm going to make the same reference mark one bay down, and that'll give me the axis of the building, and then I can draw perpendicular to that to measure across 12'6" and 3/32. Another trick is using the laser at a remote location. When I get the dot centered on that line, I can drop a point with a square anywhere along that laser line, and it'll be perpendicular, or actually parallel to the axis of the building. All I'm doing to make that adjustment is tapping the back edge of the laser with the pencil. Just light taps are all it takes. I actually moved it a little bit too far. I'm going to move it back. Believe it or not, this board is straight. I cut it on the chop saw. So if I come out here and if I split my laser line right on the edge, so there's my reference line, 12'6" and 3/32 on either side of that is the end of my beam. I just have to project those points up and make those marks, corresponding marks on the underside of the rafter beam, and that'll be my reference for when the trolley beam is perfectly centered. From our reference line, I like to lay the tape. I usually use 2 inches as my starting point. Eliminates error of whether the end of the tape is pushed in or pulled out. I bet you didn't know that's why the hook on a tape is loose. It actually has a same amount of slop as the thickness of the blade. But if you lay a reference inch mark directly on your line, then you get a little bit more accurate result for layout work on the floor. And you can see we have some floor obstructions in the way. So with a 2-inch line as our reference, instead of 12'6", we're going to go to 12'8". And 3/32. I'm just going to go ahead and make it an 1/8. And with our plumb line of the laser on the new reference mark, we have a point on the beam that is 12'6" and 3/32 from that ridge. And it ignores the slope. It's a true horizontal measurement. So got to get a ladder up there and put a line, a perpendicular line on that spot. I don't particularly enjoy climbing up 16 feet to make marks on the beams, but I am getting used to it. So beam ends here. These lines are going to be slightly outside the ends of the beam so that I can center it. I want to put a level on top of the beam once it's butted up against the underside of the rafter here. And if the beam does not come out perfectly level, then I will add shim under, steel shim under one end or the other so that it can be tightened up against this structure but be level for the trolley. One down, one to go. Now looking to the left, we have an issue. We have an obstruction. At the point that is 12'6" and 3/32 from the center line, we land inside the foot of the lathe. Much too heavy for me to move, but basically what we have to do is hop over to the top of that and transfer our reference line so that we can shoot our vertical line up from that point. Let me show you how we do that. In a previous video, we made a reference stick that's exactly 10 feet long, and I use this for spacing the pipe clamp mounts, the unistrut mounts for our air line and for our electrical conduit. So we're going to use this 10-foot stick and prop it up and hop over top of that lathe foot. So we need to take the difference between the length of this, 10 feet, and the 12'6". We'll make a new reference line on the floor, 2'6" from the original. And then well, let me just show you. It's easier to watch this than it is to explain it. Once again, I'm using the 2-inch mark as my reference. So we're going to go 2'6" plus the additional 2 inches and the 1/8. That's our new reference. Now we set our laser, the dot, on the new reference mark. We are still hitting the underside of the beam, but now we have, you see that? Now we have a vertical beam, and we'll take our 10-foot stick, and I need to prop this up so that it is basically horizontal. Okay, now we're going to come across until we get half of a laser beam on the end of the reference stick. So basically we have come horizontally 2'6" and the 1/8 inch. We've come up vertically, and now at the end of that 10-foot reference stick we can make a mark. So we've degreased and marked the base. Plumb line on the mark. And we have transferred that point to the underside of the ceiling beam. You can see I'm about 3 feet from the current position of the hoist, which is pretty much centered over the lathe bed. You add another foot, and the farthest at the, actually 1'6". By the time you account for the trolley, and the hoist is only going to be able to go about this close to the wall of the building, so 4.5 feet from its current position. So it's gonna be a little dicey getting the lathe headstock and the lathe bed pulled up by the trolley and the hoist, and then getting it to scoot over and reset it on its sawhorses. But from that point, I've got 25 feet across the building that I could set up kind of like an assembly line of components, and then be able to lift and reposition, move the trolley back and forth. Can have the lathe bed setting this way, parallel to the axis of the building, have the headstock next to it, have a leg, and then be able to lay out the chip pan, and when it comes time, bring the lathe bed up, turn it 90, set it down over the legs in the chip pan, be able to put the headstock on, and I'll still have a fair amount of clear space if I wanted to get the truck through to unload something. It'd be a good setup, much better than a single lift point. Well, I hope you enjoyed that little lesson in measuring inside of buildings. We only did 2 points. Sometimes I'm checking maybe 30, 40, 50 critical points when I do an install at a municipal wastewater plant. And some of the installations we do are 3 and 4 stories tall. We have equipment that goes in a lot of times at a 5 or a 10-degree angle from vertical. And when you've got multiple floor penetrations, you got to get creative in doing your measurements and try to keep the number of the transfers that you do and reference points to a minimum, because each time you jump and you create a new plumb line, you add error into your measurements. So you do have to think things through and plan and try to get the fewest number of discontinuous measurements that you can. So in this example, we had one obstruction that we had to get around, which was the foot of the lathe, and that was pretty simple to just use a reference stick and create a second reference point. But you got to get creative. You got to use what you can. 5-gallon bucket makes a good vertical surface to scribe a line on. So you do what you can, you get the job done. And then hopefully when you design the equipment and spend 6 to 8 weeks engineering something, and then 6 months having it fabricated when it goes in for the contractor, that they don't have any issues or any interferences to deal with. So I've been doing this for quite some time. This was a simple example of what we go through in the field, but hope you enjoyed it, and bring you back next time with more progress on the beam. And maybe we'll even put it up, but I don't know. We got a lot of grinding to do, painting, welding, number of steps, probably 2-3 videos out before we actually put this beam in place.